Welcome to Shanti-Peace for Mathematics. In this video, we'll discuss some examples related to Charpit's method. The first example that we have here is find a complete integral of PDE, that is f is equal to p square plus q square y minus qz is equal to 0. So as we know that the auxiliary equation for the Charpit's method, so the auxiliary equations are dx upon fp, dy upon fq, dz upon pfp plus qfq, dp upon fx plus pfz is equal to minus dq upon fy plus qfz. So let us calculate what is fp for this function. This is function f. So dx upon fp is, you know, said as 2py is equal to dy upon fq, you have 2qy minus z, then dz upon pfp plus qfq, that is a multiplication of this one with p, that is 2p square y plus 2q square y minus qz is equal to minus dp upon fx, a derivative of this with respect to x will be 0, plus p into fz, the derivative of this with respect to z will be minus q, and plus into p is there, so it will be minus pq will be there, is equal to minus dq upon fy, derivative of this one with respect to y will gives me p square plus q square, and the q into fz, the derivative of this one with respect to z is minus q, and here it is plus q into fz, so it is minus q square will be there. And if you simplify whole this quantity, the first two things will write as it is. So therefore we have dx upon 2py is equal to dy upon 2qy minus z is equal to dz upon, just observe that this term, from the first two terms 2y is common out, then it will be written as 2y p square plus q square minus qz, but p square plus q square into y will be, I can write down from this, it is p square plus q square y is equal to qz. So this quantity will be 2qz minus qz. So that is 2qz minus qz is equal to dp upon, just observe that this minus will be cancelled out, we will have pq is equal to dq upon, here you just observe that this q square will be cancelled out, so we will have the p square. And now we need to use any two of this equation or some operation on that, we will need to find out one solution of this. So if I compare the last two equation, that is dp upon pq is equal to dq upon p square minus I have missed, p is cancelled out, so that will gives me p dp is equal to minus q dq, and if you integrate both sides, this will gives me p square plus q square minus a square equal to 0, and this is my function g. So here g of x, y, z pq a will be p square plus q square minus a square is equal to 0. Now we solve this second equation and the first equation, that is our given equation f. So we'll solve this f equal to 0 and g equal to 0, and we need to establish what will be the value of p and q. So let me write down both this equation here. p square plus q square y is equal to qz we have given. And the other equation is, that is g p square plus q square is equal to a square. That we can see from this. Now p square plus q square is a square. I will substitute that value here. That will gives me the value of q. So it is ay is equal to qz. So the value of q we can have, it is ay by z. And if you substitute this value of q in this equation, this will implies p square equal to a square minus q square. So that is a square minus a square y square by z square. So we take a raised to, so p square plus q square is a square. So this is a square here. So this will be a power 4 y square by z square. So now the Pfaffian equation dz is equal to phi dxy dx plus xi xyz dy. The value of phi is nothing but the whatever the value of p we have here. But here it is a p square, so we will take the square root of this. And if I take a common, from that the square root of a square will be gives me a in the square root of 1 minus a square y square by z square dx plus the xi is the value of q, that is a square y by z dy. If I take the LCM z square here and if I take out from the square root, then that will be dz is equal to a into square root of z square minus a square y square upon z dx plus a square y upon z dy. Take multiply z both sides, that will gives me z into dz is equal to a square root of z square minus a square y square dx plus a square y dy. You just observe that this is z square minus a square y square. Here it is z dz plus a square y is there. So I'll just take this term on the other side. So we'll have z dz minus a square y dy is equal to a square root of z square minus a square y square dx. Now you just observe that the derivative of the under root of this one, that means inside term, it is 2z dz. So if I multiply 2 both sides and if I divide this square root term both sides, so that will gives me 2z dz minus a square 2y dy upon square root of square root of z square minus a square y square is equal to 2 times a dx. The derivative of this term is in the numerator. So that will be writing as, therefore, integration of 2z dz minus a square 2y dy under root of z square minus a square y is equal to a 2 times dx. Now, if I take z square minus a square y square as a t, so that will gives me 2z dz minus a square 2y dy is equal to dt. So that quantity is nothing but the dt upon square root of t is equal to 2a dx. And we know that the integration of t power minus 1 by 2 is t power minus 1 by 2 plus 1 upon minus 1 by 2 plus 1 is equal to 2ax plus c. So that will gives me t power 1 by 2 and this is also 1 by 2. So if I write down 2 into t power and the value of t is this one, that is the square root of z square minus a square y square is equal to 2ax plus c. If I divide 2 and if I can write down this another constant c square or c by 2, then this equation can be written as z square minus a square y square whole raised to 1 by 2 is equal to ax plus c1, where c1 is c by 2. If I do the square, then this will be z square equal to a square y square plus ax plus c1 square. This is the complete integral for given differential equation. Let us solve another example. So find a complete integral of f is equal to x pq plus y q square minus 1 equal to 0. So as we have discussed, the auxiliary equations are for the Charpit's method is dx upon fp, dy upon fq, dz upon pfp plus qfq minus dp upon fx plus pfz minus dq upon fy plus qfz. So we have to find out what is the derivative of this function f with respect to p. So that will give me dx upon x cube is equal to dy upon the derivative of this with respect to will gives me xp plus 2y cube is equal to dz upon p dx. That means multiply this one with respect to p will be gives me x p cube plus a multiplication of this one with respect to q will be x p cube plus 2y q square is equal to minus dp upon fx. A derivative of this with respect to x will gives me p into q plus p into fz. Fz is 0, so that means into 0 is equal to minus dq upon the derivative of this one with respect to y will gives me q square into plus 0 because fz is 0. So finally, if I compare the last two equation here, that will leads to minus pq upon dq upon pq is equal to minus dq upon q square. So just observe that q will get cancelled out and minus sign is gone away. That will give you dp upon p is equal to dq upon q. So that will gives me ln of p is equal to ln of q plus ln of a. So that will gives me p equal to a into q. Now we have to solve. This is the equation g. So therefore the g is equal to p minus aq equal to 0. Solving, we have to solve this f equal to 0. What is that means? What is the function f? Is this the given function, that is xpq minus plus yq square minus 1 equal to 0, and this equation that is p equal to aq. We need to establish what will be the value of p and q in terms of xyz. So if I substitute the value of p is equal to aq in this equation, then that will leads to x into aq into q plus yq square minus 1 equal to 0. So that will gives me q square into x into a plus y equal to 1. So that means q will be 1 under root of ax plus y if I consider as positive square root. And hence the value of p, as the value of p is equal to aq, that is a upon ax plus y. So now the equation, that is a Pfaffian equation, dz is equal to phi f of xyz dx plus xi f of xyz dy. This is the value of p which we have, that is a upon square root of ax plus y dx, and this is the value of q which we have obtained here, p and q, that is 1 upon square root of ax plus y dy. So if we just observe this quantity, we can write down a dx plus dy upon square root of ax plus y, which I can write down a d of ax plus y, because the derivative of this quantity will be this much, upon square root of ax plus y. And if I consider this ax plus y as t, then this, and if I take the integration both sides, then this will gives me z equal to ax plus b whole power 1 by 2 upon 1 by 2 plus some constant, another. So what was that? Ax plus y is there, not b. Plus some constant is there. Let's say c. Multiply 2 both sides. So this will be 2 into ax plus y raised to 1 by 2 plus c. So that can be simplified as z minus c square is equal to 4 times ax plus y, and that is the complete integral in the two parameter a and c we have. Let us solve one more example. Question is, find the complete integral of the PDE f is equal to x square p square plus y square q square minus 4 equal to 0. So for the Charpit's method, the auxiliary equations are that we have obtained it, that is dx upon fp, dy upon fq, dz upon pft plus qfq minus dp upon fx plus pfz is equal to minus dq upon fy plus qfz. So this will gives me dx, the derivative of fp, sorry, derivative of f with respect to p will gives me 2xp, 2 square xp, plus dy, the derivative of this one with respect to q will gives me 2y square q. If I multiply this fp by p, will have 2 is common out, x square p square, plus if I multiply this one by q, then it is plus y square q square is equal to dp upon minus dp upon fx. The derivative of this with respect to x will gives me 2xp square. Fz is not, z is not there, so the derivative of that one is 0, is equal to minus dq upon fy, so it is 2y q square, and as the same manner fz is 0, so that means we have this. Now you just observe, from either you can compare this equation and this equation, or you can compare this one and this one, because it only contains the terms of q and y. So I'll compare this equation and this equation. So that will gives me dy upon 2y square q is equal to minus dq upon 2y q square. And you just observe that y and y into q is cancelled out, 2 is also cancelled. So we'll have left with a dy by y plus dq by q equal to some constant or 0. If I take the integration both sides, this will equal to ln y plus ln q is equal to ln some constant a, where a is a constant. So it is y into q is equal to a. So that will gives me the value of q will be a by y. Now this is my function g, that is a g is equal to qy minus a equal to 0. Now we have to solve this function g equal to 0 and f equal to 0 and obtain the value of p and q in terms of x, y, z. So here the value of q is this. So q we have is equal to a by y and the function f we have given it is x square p square plus y square q square minus 4 equal to 0. If I substitute the value of q here, will gives me x square p square plus y square a square by y square minus 4 equal to 0. So this y square will get cancelled out. So we'll have x square p square is equal to, if I take this quantity on the other side, 4 minus a square. So p, the value of p, if I take the positive square root, then it is square root of 4 minus a square upon x. So this will be the value of p and this is value of q in terms of x, y, z. So now the Pfaffian equation, that is dz is equal to phi of xyz dx plus xi of xyz dy will be dz is equal to phi, the value of y is nothing but the whatever the value of p we obtain, that is the square root of 4 minus a square upon x, where this is a constant quantity, dx plus the value of xi we have, it is a by y dy. If I take the integration both the side, then we can have it is z is equal to under root of 4 a square ln of x plus a ln of y plus some constant b is there. So where a and b are the arbitrary constant, and this is our complete integral for the given PDE. Instead of taking this equation, that is this two equation, you also take this equation and you can have the solution in terms of x and you can able to find out the solution. There is not necessary that always you can pick up a particular two. You can have some logic and you can establish your logic and can be calculated in your way. So now let us solve one more example here. So question is, find the complete integral of z square into 1 plus p square plus q square equal to 1. So the auxiliary equations of these equations are, that is using the Charpit's method, we have dx upon fp. Now I will not write the whole auxiliary equation, I just directly write down what is fp, that is z square into p 2, because derivative of this p square will be 2p and z square is multiplied with that. This is fq, that is gives me 2z square q. Now we have dz upon pfp plus q, so that 2 is common out, z square is also common out. We'll have in bracket p square plus q square is equal to d minus dp upon fx. Fx, x is not here, so that's why it is 0, plus p into fz, so that will gives me 2z 1 plus p square plus q square, and that is minus dq upon 2q z 1 plus p square plus q square. Now here either you can compare these two or you can have certain results, you can combine these two equation and you can have established something, and we need to have only one solution, and you can just observe that in the last two equations this 1 plus p square plus q square will get cancelled out, 2z is also cancelled, so everything is contains in terms of p and q. So if I compare this last two equation, that will gives me dp upon, and cancelling out that minus sign is also, we'll have dp upon p is equal to dq upon q, that you can just observe, that is the quantity is left. And if I take the integration, this will gives me ln of p is equal to ln of q plus some constant ln of a is there, so that will gives me p equal to aq. Now we have to solve, this is the function g of x, y, z, p, q and a is this p minus aq equal to 0. Now we have to solve this g and the function f, here it is given. and we have to establish the value of P and Q in terms of, so here P is equal to AQ, we have already obtained, and the given equation is Z square is equal to 1 plus P square plus Q square equal to 1. So if I substitute the value of P here, that will give me Z square 1 plus A square Q square plus Q square equal to 1. So that will give me 1 plus A square plus 1 is equal to 1 upon Z square into Q square is missing here. So that will give me A square plus 1 into Q square is equal to 1 minus Z square minus 1. And if you simplify this, this will give me Q square equal to 1 minus Z square upon Z square into 1 over A square plus 1. So finally the value of Q you will have, if I take the positive square root, it is square root of 1 minus Z square upon Z into 1 upon 1 plus A square. So therefore the value of P we can have A into Q, so that this is multiplied with Q, so that is A upon square root of 1 plus A square into square root of 1 plus Z square upon Z. So the Pfaffian equation that we have, so now dz is equal to phi dx xyz dx plus xi xyz dy will change to, that is phi, the value of phi we have, it is the value of P, that is A upon square root of 1 plus A square into 1 minus Z square upon Z, Z is there, you just observe, into dx plus 1 upon 1 plus A square under root of 1 minus Z square upon Z dy. If you take this quantity on the other side, so that will give me Z upon square root of 1 minus Z square is equal to, you will have here it is A dz plus Y dy upon square root of 1 plus A square. Here dz is missing. You just observe that the derivative of 1 minus Z square is minus 2Z. So I'll just multiply by minus 2Z and divide that and take the integration both the side. That will give me minus 2Z 1 minus Z square raised to 1 by 2 is equal to AX plus Y upon square root of 1 plus A square. So this is the final answer, or I can say a complete integral for the given differential equation. If you use the another method, then some can obtain the complete integral in this form also. This one is represent a equation of a sphere, and this one is also represent the equation of sphere. If you can choose certain values of some constant here, then if I can choose this B equal to M into A plus C, then we can able to convert this equation into this form. And in that sense, these two integrals are equivalent. Still, there are some another methods for the dealing with the Charpit's methods are left. They are known as some standard types of equations that we are dealing with the Charpit's method. That things I am discussing in my next video. If you like this video, please press the like button. If you have any comment, suggestion or a question, please drop down in a comment box below. See you in next video. Till then, bye bye, sayonara.